Hi everyone, wishing you a very good afternoon. Am I audible and visible now? Is there anyone in the class? Abhiram, Niharika, Tarun, audible and visible? Good afternoon, Niharika. That means I'm audible and visible. Okay. What were we discussing in the last class? Can anyone remind me of that? What we were discussing in the last class? I think we were discussing some questions. We had done some questions on projectile motion, Niharika. Yes. And I asked you to do the rest of the questions. Try them. Did you try them? The rest of the questions? Did you try the rest of the questions? Okay. So I'll give you one more day. Try them so that if there is any problem, we will discuss the rest of the question or some of the questions which are there in your notes. I will also ask the office to send you your DPP. So you can also try questions on the DPP and we can then move ahead with that. Okay. So now let us move on and get to the next topic. Up till now, what we have discussed is we have seen that if you throw something at an angle, theta, it's known as an oblique projectile. We have calculated its time of flight. We have calculated its maximum height. And we have calculated its range. We have seen some formula. In today's class, we will be discussing equation of trajectory. In today's class, we would be discussing equation of trajectory. What is this equation of trajectory? Any idea what is this equation of trajectory? Have you heard of this term equation of trajectory? Or for that matter, the term trajectory, anyone? Anyone can tell me the meaning of the word trajectory? Did I tell you in the first class what is a trajectory? Or did I tell the students in the JE batch about trajectory? Did I discuss the word trajectory to you, with you? Anyone? Okay, no answer. That means no. Okay, yeah, I got it. So again, let us go back to the initial discussion. I've thrown something at an angle theta with an initial velocity u. How does it go? Follow something like this path. It reaches its maximum height. Let us call this point as A, this point as the point of projection, and this point as point B, where it falls on ground. Now, we found out the time of flight, we have found out the maximum height, we have found out the range, we have done some questions. Now, what we got to see is it follows a particular path. That path, you can call this path, the path that it follows can be called as its trajectory. So trajectory means nothing but the path this projectile follows. You can call that path as its trajectory. Am I clear? If you understand the meaning of the word trajectory now, trajectory simply means path. Trajectory of a projectile simply means its path. Am I clear? Right? Now, let us take an example. Example number 1. This is ground. I hope you can see this. And I throw something vertically up. Something vertically up with a velocity u. something vertically up with a velocity u. What type of path this body follows? What type of a path this body follows? Anyone? What type of a path this body follows? Anyone? I throw it from point A, it goes to point B. What type of path this body follows? Anyone can tell me the answer. You know this, right? It goes from, anyone? I throw it from point A, it goes up, from A to B, it comes back. What is the path? What type of path this body follows? It's very simple. It follows a straight line path. Yes or no? Yes or no? Isn't it following a straight line path? Yes or no? It's very simple. So if I ask you, what is the trajectory of this particle? What is the trajectory of this particle? What would you say? What is the trajectory of this particle? What would you say? You will say, sir, the trajectory of the particle is a, anyone? Abhiram, Akshay, Niharika, Tarun. What is the trajectory of this particle? The trajectory of this particle is a straight line. Am I clear? The trajectory of this particle is a straight line. Am I clear? Do we understand this? Okay, Abhiram. Let me give you another example. Example number 2. Let me give you another example. Let me give you another example. A particle. If you remember, we had started motion in one dimension with this type of a question. A particle is moving like this from A to B, from A to B, from B to C, from C to D, from D to A. I ask you a question. What is the trajectory of this particle? What is the trajectory of this particle? What is the path of this particle? What type of path this particle follows? If I ask you this question, what would be your answer? What type of path this particle follows? Yes, Niharika, the path that this follows will be circular, or its trajectory is circular or circle. Am I clear? Am I clear? The trajectory is circular. So basically, trajectory refers to the path that this particle follows. It might follow a straight line path. It might follow a circular path, as you see in case number 2. Now, if I ask you, what do you think? What do you think is the trajectory of this projectile? What do you think about the trajectory of our own projectile? What type of path is this one following? Is this a straight line? Everyone, is this a straight line? No. Okay. Niharika, it is not a straight line. Do you think it is a circular path? It has a center somewhere. It has a radius which is same at all points. No, it is not circular. It is not straight line as well. Any idea what type of path this follows? Do you know of any other geometrical figure apart from straight line, circle? Obviously, this is not triangular path. Obviously, it is not a rectangular path. It's not a polygon. It's not a hexagon. Apart from straight line and circle, do you know of any other terms? Any other curved path names? Have you heard about the term parabola? Have you heard the term parabola or ellipse or hyperbola? You must be very amazed. See, every day we are learning something new. Every day is there's a famous saying. There was a movie, I think by the name of Forrest Gump. On the same Hollywood movie, one Hindi movie is also made, starring Amir Khan, some name I don't know. There was a famous dialogue in that movie which I remember still. Every day in your life is the first day of your life for the rest of your life. So every day that you wake up is actually the first day for the rest of your life. And that is true until the last day of your life. So even if you are waking one day before your last day, that is the first day for the rest of your one day. Every day we are learning something new. Now, all these things that I was talking about, circle, I talked about parabola, I talked about hyperbola, I talked about ellipse. Now you are medical guys, that's why you are probably not aware of it, but these are not different. These are all part, these are all part of a cone. These all can be generated from a cone. I hope you understand what a cone is. I hope you have, everyone loves ice cream, right? Most of the kids or people, they have ice cream in a cone. So all of you must be aware of a cone. All these circle, parabola, ellipse, hyperbola are part of cone. They can be made from a cone, cutting the cone at different angles. And therefore they are known as conic sections, sections of a cone. A particle goes straight up and straight down or moves on a horizontal road straight. The path is a straight line. When it moves in a circle, the path is circular, the trajectory is circular. In case of oblique projectile, it follows not straight line, not circle, but a path which is known as parabola or parabolic path. Do you know what type of path moon follows around Earth? What is the trajectory of moon around Earth? Anyone knows it? Trajectory of moon around Earth. Trajectory of moon around Earth. How does moon move around Earth? Along which path? It definitely does not move in a straight line. Along which path moon moves around Earth? Yes, it is the circular path. Moon moves around Earth in a circular path. It's exactly circular. Why it is so peculiar? Because moon is probably the only, and say it's a very unique thing to say. It's probably the only celestial body in the entire universe. In the entire universe. Entire universe. Universe is vast. It's way beyond our comprehension. Probably the only celestial body in the entire universe whose path is circular. Only one body that moves in a circle around Earth or around any planet or any planet around any sun or any sun around anywhere. It's the only particle, there's the only body that moves in a circular path. What is the path of Earth around sun? In what path Earth moves around sun? Any idea? Any idea? Along which path Earth moves around sun? Moon moves around Earth in a circular path. So this is the path. Moon moves around Sun. Moon moves around Earth. Moon around Earth. All these planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, Pluto. Pluto is not a planet anymore. What type of path they follow around Sun? If you don't know it, it is an ellipse. Earth moves around Sun in an elliptical path. So Moon moves around Earth in circular. Earth moves around Sun in elliptical. And if you throw something from Earth in the form of a projectile, under the condition that we discussed, what type of path it follows? It follows, yes, beta, a parabolic path. And that is what we are going to discuss in today's class. Am I clear with everyone? When I have some raised hand that we understand this, that the path that this particle moves when I throw it at an angle is parabola. Now, every path or every trajectory has an equation. Straight line has an equation. We discussed about the equation of a straight line, y is equal to mx plus c. Do we remember this? We had discussed this equation, y is equal to mx plus c, equation of a straight line. Every straight line has an equation. Yes, sir, says Niharika. What about the rest? I think the rest of the students are sleeping in the class, not good sign. Abhiram, Vasant, Tarun, I hope you are awake. Yes, he's awake. Abhiram seems to be lost. Vasant and Akshay, Pai seems to be lost. No, Abhiram is also there. So every path, every geometrical curve has an equation. Y is equal to mx plus c is the equation of a straight line. You must, even though you are from medical stream, you must be knowing the equation of a circle. Do you know the equation of a circle? Simplest equation of a circle. The simplest equation of a circle can be written as x squared plus y squared is equal to r squared. Where what does r stand for? R stands for the radius of the circle. Every geometrical path has its equation. What is the equation of an ellipse? Anyone knows it? The equation of an ellipse. You'll say, sir, we are medical guys, we don't know it, but you should be knowing it because this equation will come in the chapter of gravitation. Just a minute. Do you have any idea about the equation of an ellipse? The equation of an ellipse looks like this: x squared by a squared plus y squared by b squared is equal to 1. This is how it looks like. Any idea about equation of a parabola? The simplest equation of a parabola is y squared is equal to 4 times ax. Now you can see a difference here. You can see a difference here. It could be y squared is equal to 4ax, or it could be x squared is equal to 4ay. The equation of a parabola is in this form. Now, if you look at the various equation of a straight line, y and x, their powers are same. The powers is 1. Are you getting my point? Looking at the various equations, powers are same. Power is 1 in case of straight line. For a circle, their powers are same. Powers are 2. Their coefficients are also same. For ellipse, Their powers are same. Powers for both x and y is 2, but their coefficients are different. One has a coefficient of 1 by a square, the other has a coefficient of 1 by b square. Look at parabola. In this equation, y has a power of 2, but x has a power of 1. Can you say this? In this equation, x has a power of 2 and y has a power of 1. That is the difference between the different equations. Are you following me? I'm just giving you a brief introduction because we'll be needing this. That is why I have to tell you this. Brief introduction of how to differentiate between different equations. Both the powers are 1, straight line. Both the powers are 2, coefficient are same, circle. Both the powers are 2, coefficient different, ellipse. One power is 2, other power is 1. It becomes a parabola. Am I clear? Can I have some reason that you understood this? Equations, we are talking about equations of different types of geometrical things. Circle, equation of a circle, straight line, parabola. I'm not talking about hyperbola. Hyperbola may, instead of this plus, we have minus. So it becomes a hyperbola. Okay. Now, as I told you, this, the trajectory is a parabola. Now, this parabola must have an equation. This parabola must have an equation. And this equation is the equation of a parabola, which is the equation of the path, which can be now called as the equation of trajectory. Am I clear? So this parabola will have an equation. We can call it the equation of parabola, this parabola, or the equation of the path of the projectile, or we can call it the equation of the trajectory of the parabola, of the equation of trajectory of the projectile. Am I clear? That is what we are aspiring to do now, to find the equation of trajectory of this parabola. Now a small question. What will this equation give me? What will this equation give me? And the answer is right in front of you. The answer is right in front of you. What does equation of a straight line give you? If you know the value of x, you can find the value of y. Equation of a straight line. Or it will tell you how is the straight line. What is the slope of this straight line? How is this particle going? When x is 0, how much is y? When y is 0, how much is x? You can find out all these values from the equation. So basically, you look at the equation of a straight line, which is here, or the equation of a circle, which is here, or the equation of a parabola and ellipse, which is here, or the equation of project parabola, which is here. Equation of any curve tells me the relation. Relation of what? Equation of any curve. Equation of any curve tells us the relation of, in case of 2 dimension, the relation of x coordinate and y coordinate. Am I clear? So basically all these equations, if you look at all the equations that I have written here, they're telling you how x and y are related to each other. In case of a straight line, it is y is equal to mx plus c, relation between x and y. In case of a circle, x square plus y square is equal to r square, relation between x and y. In terms of in case of a ellipse, x square by a square plus y square by b square. So basically you are talking about a relation between x and y. Am I clear? Am I clear? Everyone, can I have some raised hands? That's how we are clear. Every equation, whether it's straight line or circle, talks about a relation between x and y. Let us go back to this now. So what will the equation of this parabola, which this particle is following, will give me? What will the equation of this parabola or equation of path or the equation of trajectory will give me? It will give you what? If at any point of trajectory, this is the point lying on the trajectory, point C is on the trajectory, point C will have X coordinate, point C will also have Y coordinate. Any point on this path, on this trajectory, will have X and Y coordinates. If I find the equation of this parabola, what will I get eventually? What will I be able to find out eventually? Or what is my task? My task would be to find out the relation between what? My task would be to find out relation between what? The task in case of finding out the equation will be to find out the relation between, yes, Niharika, I'll have to find out the relation between X and Y coordinates. Am I clear? Am I clear? So basically what we are looking at here is a way or an equation that gives me the relation between X and Y coordinates. Can I have some raised hand that we understand this, sir? Basically, the entire picture that I was creating was to make you understand that the entire thing that we want to do is find out relation between X and Y. Abhiram, Akshay, Vashant, Sai ji, I hope you are there in the class. Okay, so basically, I want to find out a relation between X and Y. How will I get the relation between X and Y? Do I have a magic wand? Do I have a magic wand? Or this is Hogwarts where you come and I create Hermione's and Harry Potter's out of you guys. I'm not Dr. Snape. I can't create. My favorite character in that is Dr. Snape. Professor Snape, I must correct myself. I'm not him. I can't create a Hermione's and Harry Potter out of you. I don't have a magic wand. How will I find out this equation? You call it equation of trajectory or whatever. How will I find it out? I do not have a magic wand. I can't wave it. How will I find if I take some point on the trajectory? Let me call this point as C. Let me call this point as O. This point C has some X coordinate. This point C has some Y coordinate. I have to find out a relation between X and Y. I don't have a magic wand. I know that I've thrown this particle with the initial velocity u. I know that I've thrown it at an angle theta. I can assume that the time it takes to go from O to C is t. Now with these emanations that I have to find out relation between X and Y. How will I do it? Can anyone suggest me some way? I don't have a magic wand that I can wand and wave and equation of trajectory comes in front of us. How will I do it? Get a relation between X and Y is my task. I know U, I know theta, I know the point C somewhere on the trajectory. Coordinates are X and Y. I've assumed that the time is T. How will I proceed to find out the equation of trajectory? Anyone? Anyone can give me? The only way I have is by using the only thing that I know is using equations of motion. That is the only ammunition, that is the only thing that I have learned. And how and where will I apply this equation of motion? I will first apply it along x-axis. What are the things that I know along x-axis? Initial velocity along x, initial velocity along x is plus u cos theta. Acceleration along x is 0. There is no acceleration. Time it takes is t seconds. So I am making equation on x-axis from which point to which point? From point O to point C. Am I clear? I am making equation on x-axis from point O to point C. I know ux, I know ax, I know t. Now I am going to use this equation. X is equal to ux into t plus half ax into t squared. Do we remember this equation? Do we remember this equation? Yes. This is equation number 2. What do we know here? We know that ax is 0. Ax is 0. So what do I get from this equation? I get x is equal to u cos theta multiplied by t. This is what I get from my x-axis. Am I clear? I've applied equation of motion along x-axis from O to C, and this is the result that I've achieved. What will I do next? What will I do next? Anyone? I will apply the same equation along vertical axis, y-axis. From which point to which point, Niharika? From which point to which point, Niharika? Yes, from point O to point C. Let us first write what are the things we know. We know the initial velocity uy is plus u sine plus u sine theta. The initial velocity is plus u sine theta. How much is the acceleration along y? It is minus g. We all know this. Can I have some raised hand that we know this? We have used this so many times. The time we also know is t. I've assumed that the time is t. Now, which equation I'm going to apply? We can take a hint from the first case. In the first case along x-axis, I'd use equation number 2. So which equation I'm going to use now? Again, the same equation. Y is equal to uy into t plus half ay into t squared. I use the same equation here. What do I get? I just put the values. Y will be equal to plus u sine theta multiplied by t plus half minus g into t square. That is what I get. Let me call this as equation number 2. And let me call this one as equation number 1. Let me call this as equation number 1. Now look at equation number 2 and equation number 1. Let us go back to what was our purpose. What was the purpose that we were doing all this? What was the purpose? What we wanted to do? We wanted to find, we wanted to find a relation between what and what? We wanted to find a relation between X and Y. Am I correct? We wanted to find a relation between X and Y. Niharika says yes. Good. What do I have now? I have from equation number 1, X in terms of T in the block. From equation number 2, I have Y in terms of T. So this T is creating a problem. So the only thing I need to do now is to remove this T. How will I remove this T? From equation number 1, I can find out the value of T. T will be equal to X upon U cos theta. Am I clear? What I have done here is I have found out the value of T from equation number 1, and I am going to put this in equation number 2 here and T squared की value here. Am I clear? Am I clear? I got the value of T from equation number 1, and I'm going to put this in equation number 2. Can I have some raise hand that we understand this, sir? Very simple. I've lowered all your hands. Can I have some raise hand that we understand this, sir? Equation number 1, we have found out the value of X. Great. And we are going to put it in equation number 2, and I'll give you the chance to become your hero. You know the process, you know the tarika, you know the way. Give me the answer. You will get Y in terms of X, and that would be the final answer or the equation of trajectory that I'm looking for. What is the value of Y in terms of X? Your time starts now. Put the value of X, put the value of time from equation number 1, put it in equation number 2, and get me the answer. I'll give you time to do this. I'll give you time to do this. Have you done this? Anyone got this answer? And now write the answer and you see how many of you got this. So the answer would be like this. Y is equal to X tan theta minus 1 by 2 G X squared by U squared cos squared theta. That is my equation of trajectory. Did you get this answer, everyone? I hope everyone got this answer. We must remember what all these things that are there in the equation. Y stands for the y coordinate. X stands for the x coordinate of the particle. Theta, tan of theta. Theta is the angle of projection. G is acceleration due to gravity. U is initial speed with which you throw the ball. Theta is again the angle of projection, and that's it. And as you can see, the power of y here is 1 and the power of x here is 2. That means this must be an equation of Yes, beta, it must be an equation of parabola. Am I clear? Am I clear? Am I clear? Do you have any doubt? Please raise it now. Okay, this is one way of writing it. I could have written it a different way. Y is equal to x tan theta minus g x squared by 2 times ux squared. Got it? How I written this now? I have substituted u cos theta as ux. Am I clear? Am I clear with the second way of writing the same equation? Am I clear? Am I clear? Can I have some raise hand that we understand this, sir? I can also write it in this fashion. Not a problem. Great. Now there is one more form of writing this. How it is derived, we'll not get into that part. I will just write the equation. It will be in this form. X tan theta taken common 1 minus x by r. I will leave the derivation of this for you to do at home when you get time. Just remember what does thing stand for here. Y stands for the y coordinate of the particle. X stands for the x coordinate of the particle. Theta stands for the angle of projection, which is the angle it makes with the x-axis. X again is the x coordinate. What does R stand for here? This new gentleman that we have achieved. R. What does R stand for here? Anyone? R stands for the range of the projectile. And remember, the value of range is, we have known it many times, u squared sine 2 theta divided by g. So that range can be put in this formula in this fashion. And these are the three different ways in which you can write this equation of trajectory. Am I clear? Is there any doubt that is in there anyone's mind? This equation represents the path of the particle, the path of the projectile, and hence this is known as the equation of trajectory of the projectile. X y is equal to x tan theta minus half gx squared by u squared cos squared theta. U cos theta can be written as ux, so you can write it as ux squared in place of u squared cos squared theta. The other way of writing is y is equal to x tan theta multiplied by inside the column 1 minus x by r. Anyone has any doubts how we have achieved this feat? Now this derivation that we have done could be used in your board exams, in your school exams. I just wanted to do this so that you understand how it is achieved, what is the equation of trajectory. If directly I would have given you the formula, would not have made much sense because you probably would not have understood what we are trying to do. And that is why this entire exercise was carried out. Now are we ready to solve some problems? To understand how and where and why we can use this equation. Are we ready for this? Sure. Here comes the first problem. Problems based on trajectory. Problems are again taken from your what? Notes. And this is the first problem, problem number 1. The trajectory of a particle is represented by this problem has come in NEET, not exactly this, the values were different. 2017 NEET. The trajectory of a particle is represented by y is equal to root 3 times x minus gx squared by 2. What is the angle of projection? Looking at the trajectory, how you can find out the angle of projection? Good question. Anyone with an answer? Shall I do this or you can do it on your own? Do you want a hint? Or you can do it on your own. Trajectory of a particle is given by the equation y is equal to root 3 times x minus gx squared by 2. What is the angle of projection? No one got the answer? No one gets the answer. It would be my duty to solve it for you. Okay, I'll do it. Since I'm not getting any responses from anyone, I will solve it for you. I hope you can do the next one in line. Okay. So the question is problem number 1 for equation of trajectory. And the equation of trajectory is given as y is equal to root 3 times x minus g x squared by 2. That is the equation of trajectory given to us. Now I can compare it with the original equation of trajectory. What was the original equation of trajectory? Anyone? What was the original equation of trajectory? The original equation of trajectory was y is equal to x tan theta minus g x squared by 2 times u x squared. I'll just write it in this form. Do we agree on this? Do we agree on step number 1 for me? Step number 1. This is my step number 1. We agree on this. Only Niharika seems to be interested in solving this question. Where are the rest of the guys? Abhiram, Tarun, Vashant, are we there, beta? Okay, we are there. This is step number 1. So basically what I'm going to do is compare both the equations. See, x, x, y, y. So this tan theta must be equal to this. Yes or no? Yes. So tan theta becomes equal to root 3. If tan theta is root 3, what is my theta? My theta would be 60 degree. And that is my angle of projection. Am I clear? Anyone has any doubt, please raise your doubts. We are clear with this question? Can I give you one more? Okay. Okay, I'll give you one more. Question number 2. Question number 2. Root 3 times y is equal to x minus root 3 times g x squared by 200. This is my equation of trajectory. This is my equation of trajectory. The question is find the angle of projection theta. That is the first question. Find the angle of projection theta. Can you get me the answer to this one? Can you get me the answer to this one? Anyone? Everyone? Anyone there with an answer? Anyone there with an answer? Niharika, can you unmute yourself and tell me how are you going to solve it? Someone gave me an answer. Solving Abhiram. Okay. Okay. Niharika, getting the answer? Okay. Trying it. Okay. Now this question looks a bit different. Don't worry. Don't panic. Take a deep breath. First, write the equation that you know. X tan theta minus g x squared by 2 times ux squared. This is the equation of the trajectory that I know. When I compare it, y must be having coefficient 1. Here, y is having coefficient of root 3. Don't worry. Don't worry. Just multiply and divide. So just multiply and divide. So basically, you take root 3y from here and you take it to the other side. So it becomes divided by root 3. And this also gets divided by root 3. Am I clear? Are you getting my step that I have done with red? So I multiplied and divided. So root 3 was in the numerator of left hand side. I have taken it to the right hand side and I have divided. Yes or no? We got this? Yes, everyone got this. Yes. Now I can take this root 3 out, this root 3 out. Now I can compare this new equation with the green original equation. Y here? Y here? Root 3 is gone already. X here? X here? No problems. Tan theta here, 1 by root 3 there. So what does that tell me? That my tan theta must be equal to 1 by root 3. Are you getting my point? Are you getting my point, everyone? If tan theta is 1 by root 3, theta must be 30 degrees. You must know the value of tan of 0. Tan of 0 is 0. Tan of 30 degrees is 1 by root 3. Tan of 45 degrees is 1. Tan of 60 degrees is root 3. And tan of 90 is undefined. So that is how you solve this question. There are also two more questions in the same question. Find out theta was the first question. Find out ux and u. These are the questions given for your homework. So in this problem, you have to find out ux. Ux means the horizontal component of velocity. To find out ux, and once you get the value of ux, you must find out the value of u, which is the initial velocity ka magnitude, yeah, initial speed. I hope you can do this question and put your solutions in the Telegram group. I would be waiting for your solutions. That's it from my end for this class. If there's any doubt, you can ask this. You can go through the lecture. The lecture would be there definitely in your app. I would be asking the office people to put the DPP in your app as well. So that will be there. If there's anything else, do let me know. Else, this is a bye from my side. I hope you stay safe, healthy, and happy. Bye bye.